Hi, I'm Rich with insideHPC, and we're here in Nolens for SC14. I'm here with Jeff Tabor from Avere. How you doing today, Jeff?
I'm doing great. How are you?
Oh, great. We got day 2 is almost done, but we couldn't come by without saying what's new with Avere. So what are you guys up to this year?
Yeah, so we just announced our virtual edge filer. It's a software-only version of our product that runs in the Amazon EC2 compute cloud.
Okay, so this is a high-performance shared kind of storage space, or how would you describe it?
Yeah. So it acts just like the physical edge filer that we've been shipping for more than 5 years now.
Yeah.
And so it runs on high-performance instances in the EC2. So we use the memory optimized instances,
Yeah.
and so we configure those with SSDs from EBS. So you basically get the same hardware up in the EC2 cloud as you would get from our physical appliances. Then you run our software, and what our software does, it has the intelligence to automatically cache the active data up in the cloud. And it pulls this data either from the Amazon S3 storage cloud,
Right.
or from your data center, from your NAS or object systems that are on your data center. And the goal there is to hide the latency
Yes.
to the storage, hold it up there close in the EC2 compute cloud, really close to the where the application is running for the customer. Because a really low latency, and it lets the application run at peak performance.
Right. Well, Jeff, we're here at supercomputing, right? It's all about speed. When we talk about optimized NAS, why wouldn't you want to optimize your NAS? I mean, it just seems to me to be self-evident.
It is, but as it turns out, we're the only ones really doing it in this way. So we're the only scalable NAS solution in the cloud. And so what this means is you'll start with 3 instances running our software,
Yeah.
and you can scale that up to 50 instances. So you can really deliver really high performance for applications you move into the cloud. So we come to supercomputing because we've been working with these customers, as I said, for more than 5 years now. So we're working with people doing genomics analysis in life sciences. They're doing seismic processing in oil and gas, software builds, and they're doing financial modeling. And so they want to move these apps, or they want to run the ability to run these apps in the compute cloud. But the problem is the latency to where the data is too long. So we hide that latency and scale to a massive performance capacity with up to 50 nodes to really deliver the performance for the performance hungry applications.
Well, I've been hearing a lot this week about HPC applications moving to the cloud and barriers coming down. It sounds like this is an enabling technology for that very thing.
It is. People are a little leery with the cloud, because it's not on their premises,
Right.
and they can't wrap their arms around it,
Yeah.
and they're concerned about the security of it a little bit. But the bursting into the cloud is a good place for these HPC people to kind of dip their toe into the waters of the cloud. And so there's not as much kind of perceived security holes there, because your data's sort of only up there briefly being operated on or processed in the compute cloud, and it's not being stored long term, so that they don't think it's as likely to be subject to like a hacker attack or something like that. So it's a good place for the HPC community to get started with the cloud.
Yeah. Now that we've got these services like AWS, how are they reacting to what you're adding to what they bring to the table?
They love it. They love it.
Yeah.
Basically, they want essentially everyone's data in the cloud, and they want to run everyone's applications in the cloud. And up until now, there have been devices they call like cloud gateways,
Yeah.
and they come from Amazon itself had a cloud gateway, and then there's some startups that have cloud gateways, but they don't scale. They tend to be like single controller solutions. They run ZFS. ZFS has no clustering capabilities, so they can't scale to the performance levels that the HPC crowd needs. And furthermore, they don't have high availability, like an active-active type failover, so it's not a very robust solution. So ours has both the scaling for performance as well as the clustering for high availability. So it's always up and always humming along.